Hello everyone, welcome back to our channel Science Rough Book. Today we are going to cover the second half of the chapter Matter in Our Surroundings. I hope you must have seen the first video. If you have not seen, the link is given in the description. I suggest you do watch the video, it will help you to understand the chapter. Now in this video we are going to cover the topics such as can matter change its shape, effects of change of temperature, effects of change of pressure and evaporation. And if you are new to our channel, press the subscription button and also press the bell icon to get the notification of our next video. So let's get started. Can matter change its shape? We know that water can exist in three states of matter, that is solid, ice, liquid, water, gas, vapor. The phenomena in which state of matter changes from one state to another and back to the original by changing the conditions of temperature and pressure is called interconversion of state of matter. Here we can say the changing of matter from one state to another and back to the first stage is known as interconversion. Terms related to change of state. First one, fusion or melting. The process of conversion of a matter from its solid state to its liquid state at a specific conditions of temperature and pressure is called fusion or melting. So here we can say fusion or melting is a process of converting a solid to a liquid at a given temperature and pressure. The definite temperature at which a solid starts melting is called melting point of that solid. So we can say the melting point of a solid is a specific temperature at which the solid starts getting converted into liquid. Melting point of ice is 0 degrees Celsius or 273 Kelvin. So here we can say at 273 Kelvin or at 0 degrees Celsius a solid starts converting into liquid, that is ice converts to water. Higher the melting point of a substance, greater will be the force of attraction between its particles. Yes, if the particles are highly bounded with having great force of attraction between them, it is possible that their melting point will also be higher, because melting point is all about giving a specific temperature to separate the molecules, that is to convert its state from solid to liquid. So greater will be the force, more energy will be required to separate them, so their melting point will also be greater. Second one, boiling. The process of conversion of a matter from its liquid state to vapor at a specific conditions of temperature and pressure is called boiling. So boiling is again a process of conversion of matter from liquid to vapor but at a given temperature and pressure. The temperature at which a liquid starts boiling at atmospheric pressure is known as boiling point. So again a boiling point would be a specific temperature at which a liquid starts converting into gaseous but at a given atmospheric pressure. Now third one, sublimation. The process of change of solid state directly into gaseous state without passing through the liquid state upon heating and reverse on cooling is known as sublimation. So sublimation is a process in which a solid directly converts to gaseous without converting into liquid form, and a gaseous again converts back to the solid without converting into liquid state. Now fourth, vaporization. The process of conversion of matter from its liquid state to gaseous at specific condition of temperature and pressure is called vaporization. Vaporization is a process, I can say, of converting a liquid state to a gaseous state. Fifth one, freezing. The process of conversion of matter from its liquid state to solid state at a specific temperature and pressure is called freezing. Freezing is a kind of a process reverse of melting. In melting, the solid converts to liquid, but in freezing, a liquid converts to a solid but at a given temperature and pressure. The temperature at which the liquid changes into solid state by giving out heat energy at 1 atm. 1 atm means the 1 atmospheric pressure, which is a normal atmospheric pressure which you can observe above the surface of water. Above the surface of water it is 1 atm, and as you go higher the atmospheric pressure decreases. On the mountains the atmospheric pressure is less, is called freezing point. So here I can say a freezing point is a point or a temperature at which the liquid changes or starts converting into solid form. Sixth one, condensation. The process of conversion of matter from its gaseous state to liquid state at specific conditions of temperature and pressure is called condensation. I would say condensation is a reverse process of evaporation. In evaporation, the liquid converts to gaseous state, but in condensation, the gaseous state converts to liquid state at a specific temperature and pressure. Activity 1.12. Here we have taken a thermometer. After switching it on, we can see that it is showing a temperature that is 37 degrees Celsius, which is a normal temperature of the surroundings. Now we will take this thermometer and will touch it with the ice cubes, and we can see after configuring the temperature shown by the thermometer is 0 degrees Celsius. That is the lowest temperature. That is what the temperature of the ice cube is. Now we'll take this ice cubes and we'll place it inside a hot water. Here we are not having the burner, but the function is the same. It is all about to supply heat energy to the ice cubes. As time passes, the ice cube will start getting melted, and it will keep on getting melted, and after some time the whole ice cubes got melt, and we will take out the glass and we will check out the temperature again with the help of the thermometer. And you have to touch the tip of the thermometer and you can again check that the temperature shown here after configuring is 0 degrees Celsius. That is the lowest temperature. So from here we can see that the water is still having the temperature that is 0 degrees Celsius. After taking it out, we will again check out the temperature that is normal, and it is showing 35 average temperature, which is again a normal temperature. Effects of change of temperature. When a solid is heated, the kinetic energy of its particles increases. Due to increase in kinetic energy, the particles undergo vibration with greater speed. So we can say when the particles were in solid form, it is not possible for them to vibrate with a greater speed because they were having less energy. But as soon as we are heating means we are providing heat energy, and heat is a form of energy. So ultimately when we are providing energy to the solid particles, they starts vibrating with a greater speed. Now the particles leave their space and start moving more freely. Means now particles are having energy, so it is possible that they can move, and they can move more freely as compared to the solid form because they were more bounded in solid form. Now at certain temperature, solid melts and is converted to liquid state. So this is the reason for conversion of a solid to a liquid. The reason is very clear, that is the increase in the energy of the particles. Now, and when particles gain more energy, space between them increases more, and hence liquid gets converted to gaseous state. Now when we are supplying more heat energy, it is possible that a liquid will get converted to a gaseous state. So I can say ultimately it's all about intermolecular space between the particles, and intermolecular space between the particles is related to the energy. So more is the energy, more will be the vibration, and because of more vibration, more space will get generated between them, And if the space increases between them, it is possible we can say a solid is converted to a liquid, and again a liquid is converted to gaseous form. So here the state changes because of supplying heat energy. When temperature decreases, the particles loses their energy and state changes from gaseous to liquid and consequently from liquid to solid. So as I have said, it is all about energy. When the energy is supplied, the state changes from solid to a liquid and liquid to a gaseous. But as soon as the energy is reduced, the state again changes from gaseous to liquid and liquid back to solid. So we can say in solid particles are having least energy, and in gaseous form particles are having highest amount of energy. There is a small picture given over here. You can observe and can learn more from this. That is, solid on heating converts to liquid, liquid on heating converts to gas, and gas on cooling converts to liquid, and liquid on cooling converts to solid. Heating means to supply energy and cool means to take out the energy or giving out the heat energy. Activity 1.13. Here we are going to perform the process of sublimation with the help of camphor. The process of sublimation can be done with the help of camphor or ammonium chloride. Here we have used camphor. Now we have switched it on and the process got started. The bottle above the burner and a cotton at the top. After some time we can see that the particles of camphor are getting sublimate. Camphor in solid state started being converted into gaseous state. We have taken the machine out and we can see most of the solid camphor got converted into gaseous form. As we can observe, the cotton placed at the top, the particles of camphor got converted into solid form and got attached with this cotton. Some particles got attached with the bottle also at the top. As we can see, the white portion in the bottle is nothing but the solid camphor. Now, understanding another important topic of the chapter, that is effects of change of pressure. The word pressure we came across many times, like in the previous definition, atmospheric pressure, at given atmospheric pressure, at 1 atp, and all those words. So let us understand pressure very properly. So here we are. Pressure and temperature determines the state of a substance, whether it will be a solid, liquid or a gas. So I can say temperature and pressure are responsible for the change of state or identification of the state of a matter. With the change in pressure, the physical state of a substance also changes. So here the physical state of a substance change because of pressure. Like take an example, there was a gaseous state. So atmospheric pressure or overall pressure will be less. So it is possible that molecules are away from each other because they are having less force. Now when the force is increased, so the molecules have to come closer to each other. So it is possible that the molecules are having, now they will be generating the intermolecular force of attraction. So the intermolecular force of attraction will be increased if you increase the pressure. Now, an increase in pressure brings the particle closer and increases the force of attraction between them. Obviously, here when the pressure is increased, the particles are forced to come closer to each other. So that is why the intermolecular force of attraction also increases, and that is why the state changes. Like from gaseous state it convert to liquid state. If you keep on applying the pressure, the liquid state may come to solid state. So this is the way it is possible. Now another figure is given downside, which will help you to understand all these three states or various forms very clearly. First one, a solid to a liquid. Then the process is called fusion. If a liquid converts back to solid, it is called solidification. A liquid converts to gas, it is called vaporization. A gas converts to liquid, it is called condensation. And in solid to gas and gas to solid, it is called sublimation process. We are following actually NCERT book, so that is why. So I guess you must be getting a clear idea about this one. Now when a high pressure is applied to a gas and its temperature is reduced, the gas is converted to a liquid. As we have seen in the previous definition, that a liquid gets, or a gas gets converted to a liquid when a high pressure is applied and a temperature is reduced. Now, the pressure in atmosphere is called atmospheric pressure. So we can say that the pressure that we are feeling every day from the atmosphere, that is called as atmospheric pressure. Its unit is atm. So you can say the unit of atmospheric pressure is atm, atmospheric pressure. At sea level, the atmospheric pressure is 1 atm, means the normal atmospheric pressure which we are also feeling every day, which is normal atmospheric pressure. Moving higher increases the atmospheric pressure. So as you move higher, like not like moving from first floor to the second floor, not that only, but moving a bit more, like you have gone to a mountain, then you have crossed more distance from the surface. So it is possible that atmospheric pressure might be low over there. You might be you might take an example when you have gone in a flight, or otherwise you have gone to a mountain. In both the cases, it is possible that the atmospheric pressure must be low. Another important topic of the chapter, evaporation. The phenomenon of change of a liquid into vapors at any temperature below its boiling point is called evaporation. Now here we have to understand there is a difference between evaporation and vaporization. First of all, let's talk about vaporization. So vaporization is a process of converting a liquid to a gas, but the temperature is higher, means at its boiling point, that is 100 degrees Celsius. Whereas this process, evaporation, this occurs at normal temperature below its boiling point. So this is also a kind of a process of converting a liquid to a gas, but here the temperature plays a major role. The temperature is not 100 degrees Celsius, it is below 100 degrees, that is its boiling point. And evaporation takes place at a normal days. Like in summer, evaporation takes place, or suppose you are having a cloth, you are having a water which is filled inside a dish, it is kept on the ground. So these are the places where evaporation takes place, whereas the vaporization takes place only at the process like we are burning it, we are boiling it, or in laboratories. Okay, so that was all. Let us move towards the next point. Particles of matter are always moving and are never at rest. At the given temperature, in any gas, liquid or a solid, there are particles with different amount of kinetic energies. Now, in case of liquids, a small fraction of particles at the surface having high kinetic energy is able to break away the force of attraction of other particles and gets converted into vapor. So here we can say the particles need to convert themselves from a liquid state to a gaseous state, and for this they need to have the energy to overcome the force of attraction. So from where do they get this energy? So the molecules on the surface, the liquid is having a surface, and on the surface or closer to the surface, the particles are there, molecules are there, they gain energy from the atmosphere, from the surroundings, and as soon as they gain the energy, they have the capability to break the force of attraction and convert themselves into gaseous state. So this is the way a liquid gets converted into vapor, by gaining the energy from the surroundings or the surface, or we can say atmosphere. So it's all about energy and converting from a liquid state to a gaseous state. Now let us understand factors affecting evaporation. First one, surface area. Evaporation is a surface phenomenon. So here we have to be very clear why it is called surface phenomenon. The reason for this is the molecules gain energy from surface, not from the bottom. Not like vaporization, where the heat energy was given from the bottom. Here the heat energy is obtained, or I can say absorbed from the surrounding. So that is why it is a surface phenomenon. Now, if surface area is increased, the rate of evaporation also increases, because more molecules are having the capability to came in contact with the atmosphere. If surface area is more molecules comes in contact with the atmosphere of the surrounding and have the chances to gain the energy from there and convert themselves to a gaseous state. For example, while putting clothes for drying, we spread them out. Yes. Whilst what is the reason for spreading them? The reason is very simple. If we spread them, there are more chances that more molecules come in contact with the atmosphere and can gain energy and convert themselves from a liquid state to a gaseous state. Now the second one, temperature. With the increase of temperature, more number of particles get enough kinetic energy to go into the vapor state. Evaporation is faster in summer than in winter. So obviously particle needs to gain energy. Now the particles are gaining energy from the atmosphere. So if the atmosphere is hot already, like summer, then it is possible that molecules can gain energy a bit faster way. What is the reason? Because there is already an atmosphere which is already having an energy. So energy can easily be transferred to the molecules. Next one, humidity. Humidity is the amount of water vapor present in air. The air around us cannot hold more than a definite amount of water vapor at a given temperature. If the amount of water in air is already high, the rate of evaporation decreases. Now here we can say the molecules of water have to gain energy to convert themselves to a gaseous form. So as soon as particles gain energy, they convert themselves and move towards the atmosphere, okay, towards our surrounding. But if there is already a high humidity, means already the molecules of water are present in the atmosphere, there is a high amount of molecules already present, means the humidity is high, then it is not possible for the molecules to create a space there, because there need to be a space for the particles of water to move towards the atmosphere. But if the atmosphere is already filled with the particles, like having a high humidity, then the rate should be reduced. The rate will definitely be reduced. The reason for this is that only, that there is no space available in the atmosphere. Next one, wind speed. It is a common observation that clothes dry faster on a windy day. With the increase in wind speed, the particles of water vapor move away with the wind, decreasing the amount of water vapor in the surroundings. Yes, as we have discussed in the previous one, humidity, that particles need a space in the atmosphere to go. Okay, that is why they have to convert themselves from solid. Next one, wind speed. It is a common observation that clothes dry faster on a windy day. With the increase in the wind speed, the particles of water vapor moves away with the wind, decreasing the amount of water vapor in the surroundings. Next one, wind speed. It is a common observation that clothes dry faster on a windy day. With the increase in wind speed, the particles of water vapor moves away with the wind, decreasing the amount of water vapor in the surrounding. As we have seen in the previous definition only, that particles needs to go from their liquid form, their liquid state, to the atmosphere. But if the atmosphere is already having high humidity, means already the particles of water are present in the atmosphere, these particles are not having the space to go there. Now if the wind is blowing, this wind will take away all the particles with itself, and now the space is generated in the atmosphere, so these particles can easily move in the atmosphere. So a wind speed increases the rate of evaporation. How does evaporation causes cooling? So let us take some examples. In an open vessel, the liquid keeps on evaporating. The particles of liquid absorb energy from surrounding. This absorption of energy from surroundings make the surroundings cool. So we have understood that in the particles there is less energy because they were in liquid form. Now as soon as they gain energy from the surroundings, they convert themselves into a vapor state. So they took energy from surroundings. Now the level of energy, that is heat energy in the surroundings, reduced. So that is why surroundings become cool. Second one, what happens when you pour some acetone, that is nail polish remover, on your palm? obviously the particles will gain energy from your palm. The particles gain energy from your palm or surroundings and evaporate, causing the palm to feel cool. Now the heat energy that was there on your palm is absorbed by the particles of acetone and thus your palm feels cool. Next one. Third example, third question. Why do we see water droplets on the outer surface of a glass containing ice cold water? We might have seen that when we are having a glass which is containing ice cold water, or sometimes ice also is kept for some time, you might have seen some droplets of water on the surface of the glass. What is the reason for this? Let us understand. When we take some ice cold water in a tumbler, soon we will see water droplets on the outer surface of the tumbler. The water vapor present in the air on coming in contact with the cold glass of water loses energy and gets converted to liquid state, which we see on as a water droplet. So you can say that the particles were there already in the atmosphere. Now these particles came in contact with the cool water, that is the cool water of the glass or ice cold water of the glass. As soon as they came in contact with this cold water, they loses their energy, and when they lose their energy they got converted into liquid form, so thus they got collected at the surface. So we can say that the water particles on the surface of the glass are not because of the water inside the glass, but they are because of the atmosphere outside the glass. Okay, so that was the end of the video. I hope this will help you to make your concepts stronger and clear. In the next video, we'll be covering the numericals of this chapter. And if you like the video, press the subscription button and also press the bell icon to get the notification of our next video. You can follow us on Instagram, Telegram, Facebook and Twitter with the name Science Rough Book. So this is Vaibhav Valsur signing off. Have a great day.